Hello my students, welcome back. Science Primary 6, second term. Unit 1. Unit 1 is talking about force and motion. And this unit consists of 2 lessons. The first lesson is about types of levers. Before we start, let me give you an examples and ask you some questions. If you have a piano and you want to change the place of this piano, which of the 2 ways is better to save a lot of time and effort? Before I will let you answer, let me explain the meaning of save effort. Of course, all of us make effort to perform. The meaning of the word perform, do. Again, of course, all of us make effort to do or perform any work or task, right? So, make effort means consume or use their energy. So, if I told you that you save effort, this means that you use a large amount of energy or only small amount of energy. Who can answer? Okay, for sure, this means that you use small amount of energy. So, if I return it back to the first question, which of the 2 ways is better to save effort or consume small amount of energy? Number 1 or number 2? Yes, for sure, number 2. Okay, why? In the past, man invented a very simple machines to perform or do heavy tasks more easily. Like what? Like the machine in picture number 2. This machine helped the man to perform the task or carry the piano from its place more easily. So, the most common simple machine are levers. And this is the name of our lesson. I'm going to explain and talk about levers in details. Examples of levers. Number 1. If we have a piece of cloth and you want to cut it like this in the picture, which is better to use, your hand or scissors? For sure, scissors is easier to cut this piece of cloth like that. So the first example of levers, scissors. Okay, number 2. Yeah, manual broom. Okay, if your mom asks you to collect the dust on the floor, which is easier to use, your hand or the manual broom to collect the dust? Yes, for sure, manual broom is easier to collect the dust. Okay, so the second example is manual broom. Number 3. Yeah, we have here wheelbarrow. If a man wants to collect the sand and change its place to another place. Okay, which is easier to move the sand? By his hand or use a wheelbarrow? Yes, wheelbarrow is easier to collect the sand. Number 4, lemon squeezer. Okay, if you have a lemon and you want to squeeze it like that, which is easier to use lemon squeezer or your hand? For sure, lemon squeezer is easier. So the examples of levers here: number 1, scissors; number 2, manual broom; number 3, wheelbarrow; and number 4, lemon squeezer. Okay, do you know that levers were first described by scientists called Archimedes? Okay, who is Archimedes? Archimedes is an ancient world genius. Okay, who described the levers? So if I ask you, what is the name of the first scientist that described the levers? Yes, Archimedes. Now I'm going to talk about levers. I will let you see this video and then complete our explanation. Okay, let's start.
Oh, do you see that as well?
Oh yes, people are pulling water out of that well. Let's go there.
Let's go.
Oh, what is this wheel?
Oh, that one? On which the rope is moving?
Yes.
This is called a pulley. It helps to pull out water easily.
But how?
Let me show you.
Let me pull it. This is so difficult.
Oh, now try to pull this bucket.
Oh, it is easy to pull.
You know, you could pull it because of the pulley. This is called a simple machine.
What are machines?
The instruments which make our work easier are called machines.
Now, I think all of us start to think about the meaning of levers. Okay, levers like what? Scissors, tongs, nutcracker, wheelbarrow, nail clipper, fishing tool. Okay, I will ask you some questions. Are all of these machines consists of rigid bar? Okay, the meaning of the word rigid, very, very strong. Okay, the second question. Are all of these machines are used to move an object? Okay, either a person affects on each machine by a force? All of these questions I will answer it now. For example, we have here lever, which is scissors. Okay, let me tell you what's meant by lever. The meaning of the word lever, it's a rigid bar. Okay, I told you before the meaning of the word rigid. Very strong. Okay, it's a rigid bar. This very strong bar may be straight or curved, like here in the picture. That rotates. This rigid bar, this very strong bar, starts to rotate around a fixed point. Can you see here in the picture the fixed point in the scissors? Yes, here, the blue point. This is called fulcrum. So, the fixed point is called fulcrum. And for sure, this rigid bar affected by effort force and resistance force. The meaning of the word effort force, the force that you can do or applied by your hand, like here in this part of lever, while the resistance force is the opposite force in the other side here in the scissors, that you can put the thing that you want to cut or move. Okay, so again, if I ask you what's meant by lever, it's a rigid bar, maybe straight or curved, that rotates around a fixed point. The fixed point called what? Fulcrum, and affected by two forces, effort force and resistance force. Let me explain the meaning of lever. Let's start this video that will explain and talk more about levers.
Oh, see here what the gardener is doing.
He's trying to move a big stone with a rod.
Yes, this rod is called lever.
Oh, lever?
Yes, let me show you its different parts.
Lever? Hey, it is fixed at one point.
Yes, the fixed part is called fulcrum. And see, he's putting force with his hands. It is called effort.
What is stone called here?
Oh, it is called the load.
Okay, from the previous video, we can explain the structure of levers. Okay, the structure of lever is three parts. The first part is fulcrum, and I will give it simple O. Okay, what is fulcrum? The fulcrum is the fixed point, or the point that never moves, which is constant on its place and never rotate with the rigid bar. So, the fixed point, or the point that never rotates or moves in the lever, is called fulcrum. Okay, if I ask you what's meant by fulcrum? Fixed point where the bar, the rigid bar, rotates around. Okay, again, if I ask you write the scientific term, the fixed point where the bar rotates around. Yes, the answer, fulcrum. Okay, the second structure, resistance force. We all know the meaning of the word force, right? Okay, the resistance force, I will give it a simple R. Okay, This force results from the weight of the body or the load. The weight of the body that I want to cut, or the weight of the body that I want to move. So, the weight of the body or the thing that I want to cut or move or collect is called or make a resistance force. So, if I ask you, write the scientific term. The force results from the weight of the body that I want to move or I want to cut. The answer? Resistance force. Okay, number 3, effort force. I will give it a symbol, F. Don't forget the symbols. Okay. The effort force is the force that exerted by man or made by the person to equal the resistance force. So if I ask you, the force that exerted by man or made by the person is called what? Yes, effort force. So the person make effort force. The body, the weight of the body that I want to move make resistance force. And the fixed point or the point that is constant, never changes its place or never rotates with the bar is called fulcrum. Okay. For sure, levers are very important for us. And here I'm going to explain the importance of levers. We have 6 importance of levers. Don't forget. Okay. Number 1, the first importance. Increasing force. Okay. What is the meaning of the word increasing force? Increase force means, for example, if you want to move a very huge stone from its place, for sure, this needs a very big force to remove it and consume or use large amounts of your energy. But if you use lever like crowbar, this will allow you to move the stone easily, right? Okay, so increase force and consume small amount of energy or effort is done by levers. So if I told you that levers are used to increase force, this means only some levers, save force as we use small force, very small force made by the person to move very huge or very heavy object. Okay, for example, number 1, wheelbarrow. Okay, number 2, nutcracker. Yes, do you know the walnut? Okay, if you want to break the walnut, you can use your hand or nutcracker. For sure, nutcracker is easy to crack this walnut, right? Okay, so to crack this walnut need a very large force from you. But if you use the nutcracker, it will let you make a very small force and crack this walnut easily. Okay, So, number 3, crowbar, and this is the example that I give to you. Okay, let's start an exercise about the previous part. Question number 1, complete. Number 1, space is a rigid bar that rotates around a fixed point called space and is affected by space and space. The answer: lever is a rigid bar that rotates around a fixed point called fulcrum and is affected by effort force and resistance force. Number 2, space is a fixed point that the bar rotates around. The answer: fulcrum is a fixed point that the bar rotates around. Number 3, any lever consists of space, space, and space. The answer: any lever consists of fulcrum, effort force, and resistance force. Question number 2, what's meant by? Number 1, fulcrum. The answer: fulcrum is a fixed point where the bar rotates around. Number 2, levers. Levers, a rigid bar that rotates around a fixed point called the fulcrum and affected by effort force and resistance force. Okay, the important number 2, increasing the distance. Some levers allow exerting force for a small distance to move an object for a longer distance. For example, if you have an amount of dust on the floor and you want to move this dust for a long distance, so you can use the lever. Okay, who can tell me which example of lever? Yes, manual broom. Manual broom will help you to increase the distance. Number 3, moving force from one place to another. Okay. For example, if you have also an amount of dust on the floor and your mom asked you to move this dust from one place to another. Okay, so you can use manual broom to help you. So, in manual broom, the force of your hand moves from upper part to lower part to collect garbage without bending. Number 4, increasing the speed. Okay, some levers increase the speed of object that affects on them. Okay, who can guess what is the kind of levers that help you to do that? Like, okay, hockey bat. The hockey bat increase the speed of the ball, right? Okay. Number 5, accuracy in performance. The meaning of this sentence is to be accurate in doing your job. Okay. Again, is to be accurate in doing your task. For example, do you know the watchmaker? Okay. If you want to change the battery of your watch, so you go to the shop and you ask him to change the battery of your watch. But the battery is very, very, very small. So you will see the man starts to use tweezers to help him to pick up the very, very small battery and change it. So to make his job accurate, he has to use tweezers. So tweezers help you to be accurate in performance. Okay, if I ask you, give reason for. Tweezers is one of the examples of accuracy in performance. The answer? Because tweezers help us to pick up very, very small objects. Okay, the last important, number 6, avoid danger. Okay, some levers are used to pick up hot, cold, and poisonous materials. For example, cool holder, do you know it? Okay, what else? Yes, ice holder. The importance of levers again. Levers are very important in our daily life. This is a very, very important give reason. Okay, the answer? Because they are used in number 1, increasing force, number 2, increasing the distance, number 3, increasing the speed, number 4, moving force from one place to another, number 5, avoid danger, number 6, accuracy in performance. Okay, let's start this exercise. Mention examples of levers used in A. Avoiding danger. Yes, the answer. Ice holder and cool holder. B. To move force from one place to another. The answer? Manual broom. Letter C. Be accurate in performance. The answer? Tweezers.
The way levers work is that a force is applied at a point, and this moves the load at another point through a balance point called the fulcrum. It's the position of these 3 points, the force, the load, and the fulcrum, that distinguishes the type or class of lever. There are 3 classes of levers: first, second, and third class. With a first class lever, the fulcrum is in the middle, and the force is on one side, and the load is on the opposite side, much like this seesaw. Other examples include scissors. Here's the force, here's the fulcrum, and the load, and also pliers. Second class levers have the load between the force and the fulcrum. For example, with this wheelbarrow, here's the fulcrum, here's the force, and then here's the load. A nutcracker is an example, and also a stapler. A third class lever has the fulcrum on one end, the force in the middle, and the load at the end. For example, with this hockey stick. This rake is a third-class lever.